So we're going to talk a little bit now about kind of an important property to know when working problems with potential and kinetic energy. And that's the concept of a reference point. And the best way to do this is to look at an example. So again, we'll say that we have some particle A and we have some particle B, and we'll say that they both have some initial velocity. B is moving with velocity VB, A is moving with velocity VA, and we'll say that there's some distance between them that we'll call RAB. Okay, and then at some later time they've moved down and closer together, so now they'll be moving a little bit faster. So we'll have VA prime, we have VB prime, and we have RAB prime. So again, we've changed, they've moved closer together. They're both moving a little bit faster because the potential energy has decreased between them. Okay, and so if we want to set this up as an equation, we say that our initial energy is 1/2 m VA squared plus 1/2 m VB squared plus the potential energy between them. Okay, and then the final energy is 1/2 m VA prime squared plus 1/2 m VB prime squared plus the potential as a function of r prime, so the new distance between them. Okay. Now remember, because this is a closed system, we're saying that the total energy doesn't change. So in other words, the change in energy, which is E final minus E initial, is equal to 0. So 0 is equal to 1/2 MA VA prime squared minus VA squared plus 1/2 m VB prime squared minus VB squared, and then plus V RAB prime minus V RAB. Okay, so now we notice this term here is just the change in kinetic energy for particle A. This term is the change in kinetic energy for particle B, and these terms are the change in potential energy. So if we move the kinetic energies to the other side, we say that the change in potential energy is equal to minus the change in kinetic energy of particle A minus the change in kinetic energy of particle B. So what we notice is all we care about are the change in energies. So we don't actually care about what the actual value of the energy is. All we care about is how much it changes by. And we'll see a little bit more how that's useful and why that actually works. But what this means is we can develop what we call a reference point. So we can have some point where we set the potential energy equal to 0, because all we really care about is the difference in the potential energy between the two cases. So in other words, we could say that this distance here will set the potential energy to 0 for this distance. So what that means is if that distance is the same distance over here, at this point the potential energy is equal to 0, and then for this further point over here we'll have some potential energy that's greater than 0 because the separation is greater. Okay. Similarly, we could have instead said that no, we want to set this distance to have potential energy equal to 0. So then that means now for this distance, in this case, the potential energy is going to be less than 0, right? Because the potential energy is less when they're closer together than when they're further away. So if we're using this as our reference point to be 0, then we're going to have a negative potential energy. Okay? And so sometimes I think this concept can disturb people a little bit. So what does it mean to have a negative energy? So all it really means is just the potential energy at that point is less than what you're using as the reference. It doesn't really have any physical meaning. Because as we'll see in the next unit, when we talk about the relationship between forces and potential energy and where it comes from, you'll see that that it doesn't really even make sense to talk about what the absolute potential energy is. So it's okay to have a negative potential energy. All that means is that we set a reference point with a higher energy than the actual energy that we have available to us in the system.